Hello everybody, now we're going to talk about minimal inhibitory concentration. What is that? That's the minimal concentration that you need of a specific antimicrobial agent to stop the bacteria from growing, from inhibiting the bacteria from growing. In this case, the antimicrobial agent that I will be using is hydrogen peroxide. Maybe you have used it before. People use it often when they have a skin cut to disinfect the area. And I'm going to determine what is the minimal concentration of hydrogen peroxide that I need in order to inhibit the growth of this bacteria here that I have in this flask. I have 6 tubes. All of them have hydrogen peroxide. The only difference between them is the concentration of hydrogen peroxide. They all have different concentrations of hydrogen peroxide. The first one has 50%. The second one has 25%. 12.5%, 6%, 3%, and 1.5%. Okay, so they all have hydrogen peroxide. Okay, you need to add the same amount of the bacteria, so I'm going to add the same amount. I'm going to add 1 milliliter of this from this flask here, 1 milliliter here, 1 milliliter here, 1 milliliter here, 1 here, and 1 milliliter to the last tube. Once I do that, once I have them all with the same bacteria, I'm going to incubate them overnight. And I did that, and this is what I got. So if you're thinking, how do I know if a bacterium was able to grow? Well, I'm gonna explain to you now. If it looks cloudy like this here, like this tube, it means that the bacteria were able to grow. If it looks clear like this, just like if actually this tube here is my negative control, I didn't add any bacteria to this tube, so definitely there was not supposed to be any growth. But if there is no growth, it's gonna look clear like this one. So this means growth, this means no growth. And actually, let me start with 1.5. So this is the tube from 1.5% hydrogen peroxide, and you can see if I compare it to my negative control, the tube that I didn't inoculate with anything, I didn't put any bacteria, you can see that the bacteria were able to grow. Okay, so that means that 1.5 wasn't enough to stop the bacteria from growing. Let's check 3%. 3%, again, it looks cloudy, just looks very cloudy too. So that means that the bacteria were able to grow in this tube also. Okay, so 3% doesn't work. 6% hydrogen peroxide, again, still is pretty cloudy compared to the negative control. That means that the bacteria here, the bacteria that are present in this tube, were able also to grow. That means that 6% hydrogen peroxide is not enough. It's not going to inhibit the growth of the bacteria. 12.5. We got it. Ooh la la. It looks as clear as the negative control. So 12.5 is inhibiting the growth of the bacteria. Did 25% hydrogen peroxide work? Yes, it did. It looks as clear as the negative control. Did 50% hydrogen peroxide work? Yes, it did. It's pretty clear also. But now remember, we're trying to find the minimum that you need in order to stop the bacteria growth. So in this case, the minimum that you need of hydrogen peroxide to stop this specific bacteria is 12.5. So 12.5 is the minimal inhibitory concentration of hydrogen peroxide to this specific bacteria. Interestingly, just because 12.5 hydrogen peroxide stopped the bacteria from growing doesn't mean that the bacteria that are in this tube are dead. In order to determine what percent of hydrogen peroxide is necessary to kill the bacterial cells, we need to talk about minimum bactericidal concentration. I have also heard it as a minimal lethal concentration, but let's stick to minimum bactericidal concentration. So let's talk about minimal bactericidal concentration. In order to determine what is the minimal bactericidal concentration, I need to use plates. Okay, and what I'm going to do is I'm going to put 100 microliters of this tube in this plate, and all the plates are neutron agar. They all just have neutron agar, and they don't have any hydrogen peroxide. These tubes don't have hydrogen peroxide. I'm going to place 100 microliters of this tube in this plate, and if the bacteria, if there's alive cells in that tube, they're going to be able to grow on the plate. I'm going to do the same thing for this tube. I'm going to put 100 microliters of this tube on this plate, and I'm going to streak it. If there are at least one cell still alive, one bacterial cell still alive in this media, in this 12.5% of hydrogen peroxide, and I put it here in this plate that doesn't have any hydrogen peroxide, it will be able to grow. I will do the same thing for this tube. I will plate 100 microliters of this tube in here, and I will plate 100 microliters of this tube in this plate. Okay, so again, all I'm doing is I'm checking if there is bacterial growth in these tubes. Okay, if there is bacterial growth on these tubes, that means that there's some cells that are still alive inside the tubes. And I did that. I will label them. I did that, and I will incubate them overnight. And this is what I got. Okay, this was like my positive control, and because I knew that the bacteria were still dividing, were still growing. So definitely, if they were still growing, that means that there must be alive cells in this tube. And indeed, when I plated, I got growth. So this is my positive control, and actually I got it right. Good. Interesting now, the 12.5% of hydrogen peroxide that inhibit the bacterial growth, it didn't kill the cells. So there are some cells still alive in this tube. And when I plated the 100 microliters, they're still alive. Now, when I plated the 25% hydrogen peroxide, there was no growth. So that means that 25% of hydrogen peroxide, it's going to kill every single cell. Did 50% work? Yes, it worked. 50% also killed every single cell of the cells that I added. But now remember, again, we're looking at the minimum. What is the minimum concentration that I need of hydrogen peroxide to kill the cells? In this case, the minimum that I need to kill the bacteria, all the bacterial cells, right, is 25% of hydrogen peroxide. So again, just to summarize, okay, 12.5% of hydrogen peroxide is the minimal inhibitory concentration, because it's the minimal concentration that I need of hydrogen peroxide to stop the bacteria from growing, and 25 is the minimal bactericidal concentration. It's the minimal concentration that I need in order to kill every single cell that is inside that tube.